How's it going?
Good, how about you?
Yeah, it's going. I'm all set up. Early this time.
Based on the list of talks, it looks like you've got to talk longer than normal.
Yeah, I have to do another talk. Yep, nobody. Trey signed up, and his talk is longer. He has a. This is a talk that he's prepping for some conference. But he's giving a talk, and that's a longer one. So, 25 minutes in that Q&A. But that does leave me giving a talk and getting ready stuff.
Yeah, you just do another 25 minutes.
No, like we say, oh, we'll line up 3 7-minute talks, and that fills an hour and 20 minutes, right? Like once you start adding in Q&A and people setting their laptops up and everything, like I think 2 talks today is perfect. My talk's not that long, but there'll probably be some Q&A.
I'm definitely interested in yours because I just used pgvector for the first time on a project.
Well, I'm not going super deep on it, so it'll be interesting, but probably you'll know most of it. I'm not some expert, to be honest. I mean, we use it on some projects at work too. And I'm kind of like trying to figure out what's working and what's not, in terms of like what actually performs, what gives you good results, that kind of thing. I've done search related stuff in the past at past jobs, and a lot of that, just figuring out like you run a bunch of queries and figure out what kind of gives you good results and then you kind of tweak to optimize that. So search is always kind of that way whenever you're building some novel search, on data that there's not already something, it's not already indexed for search, right? So the last one I was doing it for different beer varieties. So and it was always like you search for a beer and you find similar beers that are on tap near you. So we had that kind of data. And, that was what we were doing.
I found pretty quickly that pgvector's built-in filters, not the most robust selection.
You mean like the cosine distance, or what do you mean?
So the metadata I was trying to filter was I had a list of strings that I wanted any of those from a list in the metadata on Postgres, but it's the opposite of the any lookup. I can't remember. It's like a weird symbol. This was my first time with Postgres because I usually have MySQL.
Gotcha. Yeah, I'm kind of running into something similar where I have like some just blobs of text and you just want to do kind of a similarity on the blob of text. But you also have some like facets, right? Some like hard facets. This thing is about this programming language, and there's only 100 programming languages of all the programming languages. So like it's one of the 100, or something like that, right? You have these different facets, and you kind of want your vector to somehow have like you want your search to take into account the facets and the vectors. And so how do you do that? I'm kind of figuring this out now. There's a couple different techniques. I don't really talk about that in this talk, but I can talk to you a little bit about that. I wouldn't say that I've come up with something extremely robust, but like there's a couple of possibilities. You can kind of the text that you feed through the embedding, you can kind of prepend that text in there and hope that. And if the text is short, that actually sometimes works pretty well. But if you have a whole bunch of text and you're just pretending a little bit of metadata, it's not so good. But the other thing you can do is you can get back your vector and then you can like create a vector that's your facets and you kind of combine these 2 vectors. So there's kind of tricks you can do.
Is your stuff down here, right, David?
That's me. If you want to set up, there's nobody else speaking today. So
do you happen to have a USB-C up here? Because I forgot mine, but
there's a dongle for it.
Okay, no, I just meant for power, but it's also fine. We can just let the screen go black.
There's not one of
those. Do you want to take these and make these your responsibility?
Sure.
You almost said no, and then you remembered you're an organizer of the meeting.
Yep. So this is the dongle you want,
Okay.
and then HDMI.
No, I've actually got HDMI. So
Oh, okay.
I'm
Then
fine.
you just need this. I do not have a second HDMI power, and I need
That's
mine.
fine. Yeah,
because
no,
if I don't
figured.
have it,
Yeah, yours is more
streaming.
Yep.
Like I found out that like it drops into like performance or
Oh.
some like lower performance mode, and it's terrible.
Come on
To
here.
turn on
So
the projector in order to
this is the microphone, but how do I move this over here?
Projector may take a minute to cool off. Wait, what? No, start up. And I want
Oops.
projector.
Okay, that's not the screen I wanted to show
All right.
there.
Well, that kind of looks like it's working.
So minimize windows.
So this, if you're already up there, then it should come up here whenever things work. I think it's supposed to be.
And then yours is here. Oops. Oh, right. I forgot that worked that way.
I don't know why this is.
How do I? Okay, I'm also going to drag yours so we can just close my window. Beamer.
Yeah.
I've not seen Beamer in a while.
I have no idea what I'm doing here. This is not coming up.
Present as slideshow. Okay, so there's yours. There's mine.
Shut down. No. Okay, maybe it is coming up. Oh, there's just a million. Podium. Try that.
So many windows.
Let's see if I can get this going.
Cool. Well, oh yeah, it should probably show up there. You're right.
It should.
That would be a good thing.
It would. Yeah. I hope so. Device controls, maybe? Nope.
Should I grab one of the Qualcomm folks?
Let me struggle with it for a minute.
Okay.
And then hopefully it just works.
Struggling's the way you learn.
Struggling is the way you learn. That is correct. Select source.
How's the mic sound?
That sounds
Oh,
good.
that was louder than I expected it to be. How's the
this-
mic sound now? Is that
this
still
is-
good? Still
This
good.
is the
Okay.
room mic. This is the stream mic.
Oh. Okay.
I don't know why this is
Do we know how the stream mic sounds?
I mean, I'm sure it's fine. I'm
Okay.
not too worried about it.
Cool.
I'm going to click this and just hope that.
Is it streaming right now?
Yeah, but
Oh.
you're on a small picture. You're like a tiny thing in the corner.
Oh, okay.
House PC maybe?
Meaning my slides or no? What's the?
So the slides aren't projected at all.
Oh, right. Yeah, because you're not hooked into this.
There's basically like a static picture, and then you're this big in the corner. This
static
camera.
picture.
Yeah.
Oh, so it's just me.
Yeah.
There's no slides.
No.
How do you do the?
Well, no. When I toggle
will
the
be
input,
both.
and then there's the slides of the full picture,
Okay.
and you're
So
bigger.
anyone watching the stream is seeing me in the corner in some static picture, but will eventually see the slides.
Yeah,
Got it.
basically. I have no clue what I'm doing here. Maybe if I just hit self-server. No, that's not right. It's got to be one of these. Podium, house PC, maybe. I don't see the projector off. That's the weird thing.
I'm gonna go get the Qualcomm folks.
Okay.
I heard it turn on. I hear it buzzing back there a little bit.
Once
Yeah.
they walk in the room, it'll probably work, if that's how that works.
Did they like change this? Oh, something changed there. Hit the default preset. Let's see if that does it. Sure didn't.
It's making it sound like it's on. Like it's starting to warm up.
Yeah, it does take a while to warm up. So that
It's not showing up?
not yet. This screen looks different than it used to.
Huh. One second.
It might just be warming up now. I don't know.
It doesn't take that long usually. I mean,
No, it doesn't usually. And normally you see like the Epson logo or something in the
Right.
lower whatever. But I don't see it yet. But this screen is different than it used to be, I feel. This is not what it used to look like. I tried hitting podium. I don't think the settings were very helpful.
So
So I hit power, but I So like this is like shut down system. I don't think that's what I want.
Okay, okay. So just making
These
sure.
are mics.
So off, so it's on. So alright, so device controls. Vector TV.
But I know that the HDMI is working because it's up on the TVs, right?
Yes, yes.
The screen changed and I'm an idiot and old. That's kind of what I... Maybe we just hit all these green ones until one of them works. I'll let you know if I see anything. I don't see the light on. It looks kind of dim, maybe. Hard to see. I don't see anything.
Lecture.
Oh, that just changed the TVs though.
Okay, okay. Projector.
We got the wrong. Oh, something's coming out on the audio. So I think.
This is the actual source. That's going to be the podium.
Okay. It's still on the wrong thing. Okay, now this HDMI is right.
Then, so what is the other? So the lower projector goes to podium as well, right?
Okay. Well, the audio stopped, but I don't see the projector on.
Let's just put all of them on podium.
Okay.
Podium.
Still working on it, Trey.
Now he texted me to say it's on, kind of.
Yeah, you're small.
That's okay.
Yeah, not seeing the projector on. Something. Should we like power cycle it or something? Oh, that turned off the HDMI.
Right, so the back here, podium is there.
Okay, it started back up.
Oh,
I was thinking actually power cycling the projector.
Yeah, we can all-
Yeah, I don't know. I mean, the projector is not. Okay, that turned off the TVs too.
Presentations with projector.
Yes.
Okay. Oh, there we go. See?
Oh,
So
this is much simpler. This is the
Yeah,
simpler
yeah,
one. Yes, this is the screen that I've seen before.
Oh, it looks like it's turned on.
Hey,
Alright.
Ah,
magic.
That's
Well,
interesting.
that-
You have to actually go back and
Yeah,
reset and
I
then
turn it off and turn it
I
back on
didn't hit
again.
that before. Like it
Okay.
was already on that more complicated screen. Oh, but okay. Hey, look, this is working.
HDCP off, HDCP audio.
I said we don't touch anything more.
These
At all.
ones are for
Conservative
audio, right?
approach.
Check the audio.
We don't need. You're not using audio.
No, but you're not going to be recording.
well, I mean,
We don't use the.
this
mics
is the
for
audio,
recording.
so
I have
there's a separate mic right here.
There's a separate mic for recording the audio. So all it is, the audio is only to project into the room on this mic, which is working, right, Trey?
Yeah, yeah, no, it seems like it's working.
Okay. Well, let me fill up my water and tell people to start calling into the room.
Awesome.
I think we're in good shape. Thank you.
because I use OS Path all the freaking time, and I've looked at Pathlib and dabbled slightly, but
I use it now. I use it regularly. I like it better.
I haven't looked at it enough to switch over yet.
I mean, they're both fine. They both work.
Yeah.
This one I feel just has a little bit of a nicer interface.
Yeah.
There's no like, is this in OS or is it OS.path? Or is this one of the random things that's only an SHU till randomly?
Sure.
There's none of that.
I understand that. Yeah, yeah. So maybe instead of me spending 10 minutes more with it, I'll get it via Trey.
Yes. Except Trey stocks 25.
Well, all right. I can't not.
My Wi-Fi disconnect or something? My Wi-Fi disconnected, I think.
Weird.
Maybe? Oh no, just things stopped working. We're okay. All right, well, I'm gonna herd everybody in. We need to get started. It's 10 after.
I'll go do it. I like barking at people.
Okay. I'm gonna test that mic one more time.
I don't want to chase people in too early.
No, you did great. Appreciate it.
Sure. Did anybody do anything with MicroPython or those 5 picos, I wonder?
Nobody gave a talk on it today.
What's that?
Nobody gave a talk on it, did they?
Yeah, you got, oh yeah, you gave them all that. Didn't you ask people?
That was a long time ago, too. Every single person when I gave it out, I'm like, I'm gonna phone pressure you and give you a talk. And then I didn't. But then nobody gave a talk either.
Let's start cracking the whip.
I do gotta start cracking the whip.
I'm trying to think if I can offer a carrot, but I'm having a carrot ideas.
Oh no, you
I
gotta.
thought the hardware itself, the toy, would be enough.
Yeah. That was back when JFrog was sponsoring us, which was some time ago.
I think they quit.
They quit. This is a classic thing. In fact, if we don't get a pizza sponsor for next month, they will not eat pizza.
JFrog we're to switch to Nexus. Let me know. I'll sponsor pizza if you don't get it.
I mean, I'll split it with you if you want. I sponsor pizza this month.
Oh
What
shit.
happened to Neo4j? Neo4j, they gave me a lot of notice months in advance.
Oh.
They're not sponsoring.
Just like that, JC2 was gone.
Yeah.
Who's Jason Coot?
People come in.
I'm not pretty sure if you're not. No, I'm not.
He was the.
I'm not joking.
He was the DevRel person from Neo4j. He'd show up like once.
Oh yeah.
A few months.
Yeah, like once every 3 months. He was here. He was a regular.
Yeah. And he's left the.
He moved to Japan. He's still with Neo4j last I checked.
Oh good.
But Neo4j was pulling back in terms of like sponsoring meetings.
Yeah.
Classic. Yeah. All right. Well, I guess I'll do switch to full camera.
It's funny, you didn't change my settings at all. So they are even moving the mouse.
I didn't move the mouse. It went dark and then I don't know. It suspended and then unsuspended.
Okay.
But I think we're okay.
Cool.
All right. I'll just do my announcements,
Yeah, no,
and then I'm not actually. I'm gonna put my water down here so I don't spill it on your laptop. Yeah, it's a good thing. Hello, everybody. You're in the right place for San Diego Python. Hopefully, that's what you're here for. I'm David. I'm one of the organizers, and I'm glad you're here. Awesome. I do want to thank Qualcomm for having us, and specifically the engineering development team. Also, a big thanks to Drew and Urivan, who are letting people in and making sure that the meetup runs successfully. I did want to mention we are actively looking for a sponsor for the pizza. If your company would like to sponsor our meetup, get in touch with me. It's pretty cheap to do this. It's about $80 a meetup, and we're happy to do a shout out or run a slide from your company or talk about your open jobs or something like that, talk to me after or get in touch in the Discord. Awesome. Couple other small announcements. We have a meetup on Saturday. It's at 10 a.m. It's virtual. It runs in the Discord. And it's a little different than this one. There's not like a speaker lineup. Everybody's kind of in the same audio channel and they're talking about their projects and all sorts of things like that. So it's a little different than this one, but it's great and you should check it out. All the info is on our website, sandiegopython.org, including joining the Discord, which you will need to do for the Saturday meetup. There's a code of conduct on there. There's a link to our YouTube channel. Our talks are recorded almost always when I don't screw it up. And they're visible on our YouTube channel afterwards and live, actually, if you don't make it to a meetup. And that's YouTube/@SanDiegoPython if you ever want to check that out. Yeah, and then usually within a day or so, like there's timestamps and everything, so you can skip forward through all the talks and skip through the like 15 minutes that I was recording at the beginning when nothing's happening. You can just skip right through that. Awesome. In the Discord, there's a jobs channel, like a web dev channel, machine learning channel, various channels for like people who are interested in specific groups. If you want to do that, you can mute the ones that you're not interested in. It's great. Yeah, you can make it work for you. And I did want to mention that there's an upcoming conference, PyBeach, September 27th. It's in Santa Monica. It's going to be one track, one day. There's financial sponsorships available, and tickets are still available. So check it out. I think it's pybeach.com or org. It's one of the two. You'll find it if you Google PyBeach. And I have the most important announcement of the entire meetup. This is the most critical of all of them. So everybody pay attention to this. You too can become a speaker. The most important button on the website for San Diego Python, on the sandiegopython.org website, is the Speak at a Meetup button. That I would love for every one of you to hit the button and present at it doesn't have to be at the next meetup. It can be at a future meetup. You can sign up for a future meetup. You can make it work. We have 100% like survival rate of speakers. So everybody who's spoken made it. 0 deaths. We're proud of that. So you can do it. We want talks at all skill levels. So whether it's an advanced talk, whether it's an intermediate talk, whether these are like the problems you ran into with your Python environment and you asked ChatGPT about it, I want all of these talks. So please give a talk at a meetup. Awesome. That is it for announcements, I think. Yeah, Trey, you have a question? What? Oh, I didn't know about this. What's this? This is not on my notes.
I just emailed the link to you.
Oh, well, I didn't see that. You wanna, what is it about? Give me the pitch.
All about the Python programming language. It's early days, it's success, history. There's a lot of early Python history.
Does it have pictures of young Guido?
Yes.
Awesome.
There's video.
Oh, sweet. Love it. All right. Awesome. You've sold me. I'll watch it. How do I watch this? YouTube. All right. Sounds good. Very cool. So become a speaker. Check out the Python documentary, PyBeach, all the things. Without further ado, Trey is our first speaker this month. Trey Hunner is going to talk to us about Pathlib, why and how to use it. And this is a talk that will also be at PyBeach, I believe. So keep it on the down low because you heard it here. And yeah, we're streaming it, but yeah. And it's going to be a little bit longer, I think. You were aiming for 20 to 25 minutes, right? 25. All right. So I'll let you take it away. And I'll make sure to switch the HDMI. Or switch this thing so that it switches to everybody can see you. Awesome. So this is going to be a little bit of an unusual talk. David said, hit the button to give a talk. Your talk should not be a 25-minute talk. 5-minute talk, 2-minute talk, couple-minute talk is great. And honestly, on anything, when you're rehearsing for a conference, as I am, that's, I feel like, kind of the usual exception to the rule of longer talks are welcome in that case. So this is a rehearsal for PyBeach. I have put this talk together. I don't think anyone has actually seen it outside of the people who are out to see it in this room. Well, obviously me. I've rehearsed it a number of times with myself. So if you have feedback, I would love your feedback.
afterward. Either, talk to me afterward or as I'm answering questions possibly if we do that. I would love feedback because I do plan to tweak it before the conference. It is, last I timed it, a 25-minute talk. So it could go over, it could go under if I talk too fast, we'll see. And I will get started. So today, I plan to convince you that you should stop representing your file paths as strings and start using Pathlib for all of your file paths. And I'm going to fix my laptop positioning here real quick. So I help folks level up their Python skills. I run both virtual and on-site Python workshops and courses for teams. And I run Python Morsels, which is a weekly skill-building service for Python developers of all skill levels. You might have seen stickers that are floating around outside. If you haven't, ask me and I can get you one. Also, I share a Python tip every week through my newsletter, which you can find at trey.io/news. I spend a lot of time thinking about the tip I'm going to spend every Wednesday morning. So this is, if you're into that sort of thing, feel free to hop on my newsletter. For most of Python's history, file paths were represented by strings. This still works today, and it always will work. Before we really discuss Pathlib itself, I'd like to talk about why this can be messy, that is, representing file paths as strings. So there are 4 reasons that I recommend using Pathlib. 2 of them are about the various utilities that Pathlib competes with, and 2 of them are about the problem with representing file paths as strings. The alternatives of Pathlib are difficult to find and difficult to use. Also, representing file paths as strings requires deliberate effort to avoid writing buggy code. And path strings make it harder to distinguish between a path and any other string. I'd like to address each of these before we talk about Pathlib all that much itself. So we're going to hop in a time machine. We're going to roll the clock back about 330 million seconds. The year is now 2015. The Late Show with Stephen Colbert has just premiered. Some interesting guests were on it. Look at the first month or so of The Late Show. If you're interested, TikTok didn't exist yet at all, but there was something called Vine that everyone was using, which doesn't exist anymore today. Everyone's also arguing about whether the dress is black and blue or white and gold. And everyone was preparing their Left Shark Halloween costumes. Also, we're still using Python 2.7, which won't be end-of-life for another 5 years. When we need to work with file paths, there are 4 standard library modules that we might reach for: OS, os.path, glob, and shutil. The shutil module has a bunch of high-level file-related stuff, including 7 different functions for copying files and directories. The glob module is much simpler. There's iglob, glob, and 2 other functions. The os.path module is for manipulating file paths, splitting paths apart, joining them together, and generally asking questions of file paths. The OS module is a bit more complex. The Python standard library has 2 modules that I think act as junk drawers. The sys module is the junk drawer for stuff related to the Python interpreter. The OS module is the junk drawer for stuff related to the computer that your code is running on. The OS module has lots of file-related stuff and a bunch of other stuff. There are utilities for getting the current working directory and for changing directories, for changing file modes, stuff for working with symbolic links and hard links, utilities for traversing the file system, utilities for renaming and replacing files, and utilities for making directories. These are most of the file-related utilities in Python's OS module, but this is not everything that's in the OS module. There's also all of this. And this. And this. Also this. And this. Also this. Plus this. That's everything in the OS module. Well, that's all the functions in the OS module. There's also dozens of constants that I'm not going to show you. My point in dumping out the contents of the OS junk drawer is to point out how difficult it can be to find these dozen-ish file-related utilities that are in the OS module. And these are just the file-related utilities that are in the OS module. This doesn't include everything that's in os.path, shutil, and glob. These are most of the useful path-related utilities that are in Python's OS, os.path, shutil, and glob modules. I say most because I removed about 10 things from this slide that didn't fit. Back in 2015 in Python 2.7, our only option when working with file paths was to go hunting for these utilities when we needed them. So I think we can agree at this point that the various path-related utilities scattered throughout the Python standard library are difficult to find. But do we even need these utility functions? If we're representing file paths as strings, couldn't we just manipulate the strings with string operations? I mean, that's what strings are good at. This code was taken from a Django project. It sets base dir to the directory above the current file's directory, and it sets templates dir to the templates subdirectory within that base directory. But these file paths are just strings. So instead of using os.path.dirname, everything disappeared. No worries.
I saw this.
You saw this coming?
I saw this coming.
Does it need to start up again?
Yeah. This
Oh.
has happened like most meetups now.
Really?
Randomly.
Huh. Oh, the mic came back on, so that's a good
Yeah.
sign. Yep, there's the projector.
Okay. This is not quite up.
Yeah,
there,
that's
but
going to take a little while.
But yeah, this has happened in a couple meetups, not every one.
Okay. Well, I'll keep going because the slide will come back in a moment. So instead of using os.path.dirname and os.path.join, excellent, couldn't we just use the string rsplit method and string concatenation? This second way of doing things is shorter, but it's probably buggy on Windows, which usually uses backslash instead of forward slashes for file paths. Now, we could have relied on os.sep to make this code work on all operating systems, but I think this last code is actually less readable than the os.path version that we started with. Also, depending on where our paths came from, we might accidentally end up with a mix of forward slashes and backslashes, which is technically valid on Windows, but it also looks really weird, which is why the many os.path utilities are useful, but performing string manipulations on file paths is tempting, and it can get us into trouble. If we forget to use these utilities and instead perform string manipulations, our path strings might end up buggy. So, using strings to represent paths can easily lead to bugs unless we're very careful to use the proper path manipulation tools. But potential bugs aren't the only issue with representing paths as strings. Stringly typed code is code that passes strings around when a better type exists. This code is stringly typed. It uses a string to represent a date. This code uses the datetime module to represent a date instead. I prefer this second block of code. It's a bit easier to work with date objects than with strings, and we automatically get a bit more certainty about whether the data that we're working with is valid data. As we've discussed, old Python code always used strings to represent file paths. This was the norm. I would argue that this is stringly typed code, though. There is a better way to write this code, using the path class from Python's Pathlib module. Now, we'll address the differences between these two coding styles in a moment, but I would like to acknowledge first the fact that using path objects instead of strings makes it easier to distinguish file names and any other string in our code. If your code uses type annotations, a file path might look just like any other string, which can make it harder to catch path-related bugs, and it can make it harder to reason about your code. So, we've seen that the alternatives to Pathlib are difficult to find, that path strings are error-prone, and that path strings also make it difficult to distinguish between paths and non-path strings. I'd like to quickly address my last point by comparison to Pathlib. Let's compare the readability of code that represents paths as strings to the same code that uses pathlib.path objects. So this code that we've already seen represents paths using strings. I find that I need to read this code inside out. We get the absolute path, then the parent directory, and then its parent directory. Instead of this code, which uses strings for paths, I prefer this code, which uses pathlib.path objects. I read this from left to right. We resolve the path into an absolute path, we get the parent directory, and then we get its parent directory. When using strings as paths, we need to use nested function calls. But when we use path objects, we can use chained methods and attributes instead. Personally, I think the Pathlib version reads much more naturally. Here's another example, comparing the glob module and Pathlib. Instead of joining a path and then passing it to iglob, with Pathlib, we can just call the rglob method on the path object. Shorter code isn't always more readable, but when the shorter code has less noise, it usually is. I very often need to open a file, read the whole contents of the file into a string, and then close the file. With Pathlib, there's a convenience method for that. Instead of using the open function, we could just call the read text method on the path object. The methods on the pathlib.path class are a bit more deliberately designed than many of the other path-related utilities hiding in Python. If you wanted to make a directory without Pathlib, you would either use os.mkdir or os.makeDirs, depending on whether you wanted to make parent directories automatically. With path objects, the mkdir method includes the ability to make missing parent directories thanks to the optional parents keyword argument. Copying files is another good example of where Pathlib shines. In Python 3.14, which isn't released yet, but it'll be out in the next couple months, Pathlib's path class will have a copy method and a copy into method. Before these two methods existed, we needed to reach for either copy file, copy, copy to, or copy tree from shutil. All of these have slightly different uses, and I always need to read the documentation to figure out which of these I'm supposed to use to copy a file. Copy to is often the one I need. So code that uses Pathlib is often more readable than the alternative. But how does Pathlib actually work? Well, the Pathlib module contains pretty much one thing, a class called path. So understanding Pathlib means understanding path objects in the path class. The path class accepts a string, which represents a file path, and it returns a path object. The path object that we get will either be a POSIX path or a Windows path, depending on the operating system that the code is running on. And both types support all the same features, but they normalize paths differently. Now, we don't normally need to worry about the difference between these because the path object should just work the way we'd expect it to on the operating system the code is running on. These are pretty much all of the useful features that the path class supports. Most of these are methods that you can call on individual path objects. Some of these are attributes of the path objects, and two of these are class methods. One returns the current working directory, and the other returns the user's home directory. Technically, these are only about half of the 70-ish methods and attributes that are on path objects. These are the rest of those methods and attributes, but I don't find myself using these ones very often. So path objects have lots of useful features built in, all in one place. But what happens when you actually want to use a path object as a file path? Back when Pathlib was first added to Python, in order to actually use a path object, you needed to convert the path to a string. Today, that's completely unnecessary because Python's built-in open function accepts path objects. The open function used to only accept strings, but since Python 3.6, open works with strings and with pathlib.path objects. In fact, pretty much every utility in Python that accepts a file path as a string will also accept a path object. Whether you need to change directories, change the ownership of a file, connect to a SQLite database, log to a file, create a zip file, or run a subprocess, you could use pathlib.path objects instead of using path strings. You don't need to convert path objects back to strings. Every standard library function that should accept path objects does. In fact, even standard library utilities which are specifically designed for path strings will also usually work with path objects. If you're still using os.path functions, that's okay. All of these functions also accept pathlib.path objects. Every path-related utility that we saw earlier accepts a file path string, will also accept a pathlib.path object. So you can usually pass path objects to legacy code that was written without Pathlib in mind, and it will often just work. Even most third-party libraries that handle file paths will usually also accept pathlib.path objects. Django, Pandas, Pillow, PyTest, and Click all support path objects. Most modern Python libraries work just fine with Pathlib. So Pathlib is great, but in practice, how should you start using it in your code? Pretty much anytime you encounter a string that represents a file path, you'll pass that string to the path class to get a path object. When you're writing cross-platform compatible code, you'll want to use forward slashes in the string literals that you pass to pathlib.path, but don't worry about backslashes on Windows. If you do end up with a backslash separated path on a Windows machine, Pathlib will normalize it for you automatically. On Windows, this path with backslashes will be interpreted the exact same way as the path with forward slashes. Now, once you have a path, there are lots of things that you can do with it. If your path object represents a directory, you may end up joining your path with a file name. You can do that with the join path method or with the slash operator, which looked a bit weird to me at first, but now that I'm used to it, I actually find this pretty readable. Also, the path class can accept multiple arguments to join together, and those arguments can either be strings or path objects. So this joins our home directory path with this config file name. All three of these approaches return equivalent path objects, and none of these is necessarily better than the others, although you'll usually only see that third approach if you're not sure whether home is a path object or a string. It's a way to convert it all back into paths. Now, I always found the functions in os.path to be unfortunately named, shortened words all squished together. With Pathlib, all the same functionality exists as either methods or attributes on the path class, and they're all pretty well named. I very much prefer the name attribute over the base name function, the parent attribute over the dir name function, and the suffix attribute over calling the splitExt function and accessing index 1 from its return value. If you're looking for a Pathlib cheat sheet, this slide I actually would not recommend as a cheat sheet. Instead, you can find a couple of cheat sheet tables in that first URL, which is an article that I wrote on Pathlib. And there's also a table at the bottom of the Pathlib documentation, which is where that second URL goes to. Now, this talk is about Pathlib, but it isn't just about Pathlib. Code that uses Pathlib can also work with code that inherits from pathlib.path. And also, it's possible to actually practice duck typing when it comes to path objects. Since Python 3.12, you can extend the functionality of Pathlib using inheritance. If you'd like to make your own custom path objects that include a method to change directories, you can do that. You'll just inherit from pathlib.path and then use your own custom better path class the same way you'd use the pathlib.path class, and it just works. If you need to attach metadata to a custom path object, you can actually override a with segments method to ensure that the metadata in your path is preserved for any new path that's derived from your existing path. In our case, we have a path subclass with an additional repo root attribute. So if we get our path's parent directory, our repo root attribute will actually be maintained on the new get path object that's generated. The same thing would happen if we joined our path with another path. All methods that generate new paths call the with segments method. Now, this pattern makes it pretty easy to make specialized path subclasses. Probably won't use this much yourself, but it does mean if you ever needed it, it's there. You can extend Pathlib. So you can make a sort of Pathlib alternative by inheriting from pathlib.path. But you can also make a Pathlib alternative through duck typing. An object that acts like a list or a tuple is a sequence. An object that acts like a dictionary is a mapping. An object that acts like a file is a file-like object. And an object that can be used where path objects can be used is a path-like object. If it looks like a duck and quacks like a duck, it's a duck. We care about behavior in Python more than we care about the types of objects. And the same thing applies with Pathlib. If it's accepted by utilities that accept path objects, then it's a path-like object. PEP 519 defined the path-like protocol. All path-like objects are accepted by open, and any other built-in function that works with that is a path tool that accepts file paths. The only thing that's needed for a path-like object is a dunder fs path method. That one method will allow an object to be accepted by all of Python's many path-accepting functions. And any third-party utility that wants to convert a path-like object into a string can use the os.fs path function to do so. This PEP allows for a whole ecosystem of path-like objects beyond just Pathlib. For example, here's a class called myPath, which does not inherit from pathlib.path. And yet, instances of this class actually work with the built-in open function because this class has a dunder fs path method. The ability to make an object that acts like a path allows for third-party libraries that work everywhere that Pathlib does. Before we conclude, I'd like to make sure to discuss a couple common mistakes that new Pathlib users often make. The path class has an open method. Back in Python 3.5, the open method was the official way to get an open file out of a path object. The path-like interface was added in Python 3.6, thanks to PEP 519 that we just discussed. So now path objects work with the built-in open function. There is no reason to use the open method anymore. The open method only exists because there were two versions of Python that included pathlib before the open function worked with pathlib. So I recommend against using the open method. I consider the open method on path objects to be a relic from an earlier version of Python. If I need to display a path to an end user or log it to a file, I'll often implicitly convert it to a string by using it in a print call or in an f string. And that's useful. But don't convert path objects to strings when you don't need to. If you think you need to convert a path object to a string, you probably don't. Also, don't forget that the path constructor can accept multiple arguments. If you have a directory string and a file string, and you'd like to join them together, you don't need to make a path object and then use the join path or the slash operator. You can just pass both of your strings to the path class. This even works if you're not sure whether one of these is already a path object. So with Pathlib, it's easy to write code that works on all operating systems. Many common path operations are even simpler than they were before, and you get to avoid awkward stringly typed code. Pathlib can also help you make your code more readable and more maintainable. But there's a very common concern that I hear about Pathlib that I feel is unwarranted. Pathlib is slow. It is true that Pathlib can be slower for some operations, but readability is sometimes worth a small performance penalty. So I searched 400,000 files with os.walk and with the pathlib walk method, and Pathlib wasn't any slower. Except the walk method on pathlib objects deliberately returns strings, which is a little bit of a cheat because strings are more performant than path objects. So when I converted all 400,000 strings back into path objects in order to ask questions of them, my code did slow down. Although, unless I'm actually planning to process many thousands of files, this kind of slowdown is probably not very significant. Most path operations are not in tight loops like this was. Readability is usually more important than micro-optimizations. Use the right tool for the right job. Optimize only when it really matters. So Pathlib isn't just a different API. It's about acknowledging that file paths are important enough to warrant their own data type. A data type that's designed to make file path operations easy. It's also about representing file paths properly. Thank you. So questions, feedback, I welcome all of it. Maybe let's do questions first. Yep.
I noticed you providing examples on the use cases of passing arguments to the path definition by using a pair of arguments.
Right.
Why do you have more?
You can pass in as many as you want. That's a good point. I didn't show any cases where you passed in many arguments. Although I do find I rarely need to do that. I usually don't have many parts of a file path that I need to turn back into a path. They call them segments in Pathlib land, but I have done that before. For example, if you had a list of them, you could use the star operator to join them all together. But yeah, that is possible to do. The path class accepts any number of arguments. Yep, Hobson.
So another gotcha. I wasted my team's 3 days worth of my team's time when I used a path object in a URL. So when you try to append it to a URL, and some of your teammates are on Windows, that's
Yep.
F them up. So you use a POSIX path.
Right, so actually on a path object, there is an as POSIX method, and it will give you, I think, the string representation using forward slashes. However, I don't even know if that's a good idea in URLs because there could be some weird case where like a network file, or I mean, if you know your system, you know your system. But yeah, as POSIX is definitely a thing that, like, if you want your paths to always be represented the same way, regardless of operating system, Pathlib, both Pathlib and os.path can be a bit of a liability there because they're assuming that you want backslashes in the representation on Windows. Yeah, that's a good point. Drew, did you have a question?
Is it okay to use the term forward slash?
Instead of forward slash, what did I say? Yes, I would say forward slash is the acceptable term, as opposed to a backslash. If you had a different question, ask me afterward. Well, if you do have feedback, maybe we can chat afterward about it. But I plan to tweak this at least somewhat, and I'm guessing there were probably some parts that were either, too fast or didn't feel necessary, anything like that. So, let me know afterward. You want to give your talk?
Sure.
Excellent.
My talk,
Here, let me bring up your slides.
which is on your computer.
Yeah, no, there we go. Oh, wait, do you have speaker notes?
What?
Do you have speaker notes?
They're here.
Oh, they're there. Excellent.
Yeah.
Just hit the, you know how to
I
do
have
it.
this like 15-year-old iPad, which I turn off except for once a month. Awesome. Oh, where did it go? Oh, I guess it's over there. Okay. Oh, this is working. Okay, awesome. Cool. Thank you, Trey. I'm David, and I'm giving a talk today because we didn't have enough speakers lined up. So I usually have a bunch of talks all in my back pocket ready to go, and this is one of them that I think I threw up, and this was the second most popular talk that people wanted. I gave the other most popular talk last month when we also didn't have enough speakers. So please go to sandiegopython.org, sign up, please give a talk. Awesome. So I'm going to talk about using pgvector with Python and Django and what that even means and why you might want to do it. So first of all, what is pgvector and why would you care? pgvector is a Postgres extension, and it is for storing vectors, which I'm going to go into a lot more detail on, right in your database. So you don't need a separate vector database. You can store it right in the same tables that you store other things in. And this is nice. You don't now suddenly have 2 data stores. You don't suddenly have to have 2 things that are up all the time. Your ops team will be less mad at you, which is great. It's supported on all the major clouds, which is nice. So like if you're already on Azure or AWS or something, this is just a thing that you can turn on if you want it. And it allows you to do nearest neighbor type similarity searches on these vectors. And that's really cool. You can do it directly in SQL. Your framework or ORM or something probably supports it, which is great. And there's all sorts of searches you can do. You can even kind of compare like a vector that you got from words against an image. I'm not going to dive into all these details, but there's a bunch of options here. If your vector just had 2 or 3 values, like it was a 2D vector or a 3D vector or something like this, you might not bother with this. You might still, but you might not bother with it. You could just have 2 or 3 fields on your database. But when you have a lot, many, when your vectors are very long, this becomes really useful. One of the things that you can use a vector for is an embedding. It's not the only thing, but this is very common. And an embedding, this is kind of what Wikipedia says an embedding is, but basically an embedding in natural language, it's possible to turn a word or a phrase or a sentence or a paragraph or even something longer than that, an image maybe, lots of things. That's not really natural language processing. Anyway, you can turn all of these things into a vector. So you've turned it into some multi-dimensional vector. You know, rather than having 3 values, it might have 1,024 values or 384 values or something like that. And what's nice about them is they encode the meaning of these words and phrases and sentences and whatever, such that similar words, phrases, etc., are close by in this multidimensional space. So you can, again, run a similarity on them. And this is really powerful because computers are really good at comparing numbers. Who knew? Not people who do computer science all the time, certainly. Anyway, these embeddings can come from like a model that you've trained. There are great embedding models that are commercial. You can, pay them. You can pay to use them. They're extremely cheap. But you can also download small ones, download big ones, use them yourself. And one thing to talk about is generating an embedding is much, much cheaper than generating some sort of a chat response from a chatbot. And once you have the embedding, you don't need to go back to the chatbot necessarily or some API. You can do these numerical comparisons yourself in your own code, in your own database, or whatever you want to do. I figured I'd give some examples. So in this example, this is like a classic example from, I don't know if Hobson's book uses this example because I haven't read Hobson's book, sorry Hobson. But this is like a classic example from the literature. And in this example, they get a vector for Berlin, they get a vector for Germany, they get a vector for Paris, and they get a vector for France. And you'll notice that the Paris and France vectors and the Berlin and Germany vectors, these are somewhat close. And even the Germany and France vectors, these are somewhat close. Those are neighboring countries. But if you try to compare Berlin to France, or you try to compare Paris to Berlin, they're not as close. They're further away in this multidimensional vector space. But where things get kind of interesting here is I can take the Berlin vector, I can subtract the Germany vector from Berlin somehow, magically. I can add the France vector to my vector that I've created, and this is somewhat close to the Paris vector. So I took kind of Berlin, subtracted Germany, added France, and I have something somewhat close to Paris. That's pretty awesome. And this is real data. I actually did this. This uses like the OpenAI, like their cheapest embedding model, which is extremely cheap. It's like 2 cents per million tokens or something like, I don't know how you do it for that cost, actually. Since this is like a classic example from the literature, there's even a photo of it, or an image. I didn't generate this image. I totally stole it from Wikipedia. But this kind of shows you how this is projecting it from some multi-dimensional space into 2D space, which it's not. It's some hundreds of dimensional space. But you can see how this capital of the country kind of thing is encoded into this vector space a little bit. And if you can add and subtract from these values and kind of get something that vaguely makes sense. You can do traditional computer science on these things, or traditional mathematics, and it just works. And it's vaguely predictable, mostly predictable, more predictable than a lot of things with a chatbot. So I think that this is really cool. I wanted to dive in because it's the Python Meetup. I'm going to show some more examples in Python and Django, or some examples in Python, and I'm going to do an example using Django. And this uses the Python module from pgvector. So they have a Python module which has even a Django submodule, which has things like defining a Django vector field, so a model field that is for storing vectors. And you can see in this example, I kind of have a document, it has a vector, and then I can kind of run a search on it. I should also mention these models, they work just fine with normal Django migrations, so you can add columns, run your migrations, they work exactly the same. And in this example, I have this model for a document, I'm generating an embedding for each one, saving it in my database, and then it's possible to search these documents, find related documents based on a query. So if I have all my documents somehow put through this embedding model and somebody types in a query, I can put my query through the same embedding model and say, what are the closest documents to this query that somebody has typed in? And that's really powerful. you can't really compare if a different model generated the embedding and you're trying to query it with putting your text through a different model. That doesn't really work. But as long as the models are the same, this works pretty well. And I wanted to talk about why you should care about this, because it has a number of advantages over regular old plain text search or using keywords or something like that. Firstly, as we saw with the countries and capitals example, this is encoded some semantic meaning into your search. So, for example, if you were trying to search for something about dogs and the document doesn't have anything about dogs, but it has something about poodles, this might know about that because the fact that a poodle is a type of dog is hopefully that's embedded into the vector that you get from this model. The model knows about that, and then this search is capturing that similarity in a more powerful way than a keyword would. So this is kind of a semantic search, if you will. Let me see, I got lost a little bit. Oh, these comparisons return a score rather than just kind of, yeah, this keyword was present or not. And this lets you sort of say, how close are they? And you can kind of order your results from your database based on this. That's really powerful. We also saw how you can run mathematical operations on them, adding and subtracting. Averaging is also very powerful. So if you have a whole bunch of embeddings, you can take the average of them if they're somehow related and you get some average value for it. And I'm not going to discuss it because I've never used this myself, but there are models that work across formats. So they work on images, or they work on audio, or they work on video. And because of that, it's possible to find images, for example, that are similar to the words you search for. So you can have a search that kind of works against images, even though you've just typed in words. This seems really powerful, but I assume that this is how image searching works, which was always a mystery to me. But it probably uses other things too, like the words that are close. But anyway, this would be really powerful for that. I did want to, I know this talk is just an introduction, but I did want to give a few tips since I've been using this, not for very long, but so just a couple things that I've learned. One is to consider storing embeddings in their own table and associate it with the model that generated it. And this is for a couple different reasons. Firstly, comparing embeddings across models doesn't really make sense. So they encoded different values in different ways. So you want to store the model that generated the embedding alongside the embedding. The other thing is you might upgrade. Models get better over time. And you want to be able to say, hey, I'm going to use the new stuff, which is now better than the old stuff. And if your database already supports this, you can just rerun all the new embeddings with the new model and just switch it over to use the new model when it's all loaded and ready and done and everything like that. So that's really cool. The other thing is if you're using a paid API and the company that you're paying decides, yeah, that API you were using, we're getting rid of it. Got to use the new one. And if they do that, that kind of sucks because you have to rerun all your embeddings. This might cost money. But hopefully your database already supports it, and at least that way you can accommodate it with less pain than normal. So yeah, this is really powerful. The other thing that's pretty cool is, and this is a pretty common tip, you can generate embeddings not for a whole document. It kind of depends on how long your document is kind of an arbitrary term. It could be, a gigantic Word document, somebody's 1,000-page dissertation. It could be like just a paragraph. But you can generate embeddings from text that is comparable sizes. So you can have embeddings that are per paragraph or per sentence or per section of something. Or you could even say, hey, I'm going to chop the text up based on a fixed length and run my embedding based on that. So they kind of call this chunking. A lot of models also have token limits where there's a maximum amount of tokens you can send to generate the embedding. This lets you stay under that limit. Whatever documents you're kind of generating embeddings for, hopefully they have paragraphs or sections or something like that. But these paragraphs might also have different meanings. For example, if I were generating embeddings for something like the Python official documentation, some of the official documentation is super long and has sections that are only vaguely related to each other. But if you took embeddings for each section, you can get an embedding that very accurately represents that section and then run a search that matches just a section rather than some whole document. The other thing is if you do, for some reason, need a whole document embedding and you have a whole bunch of chunked embeddings, I guess I'll call them, you could take the average. So you could just take all of your embeddings and take the average. It may not be the best, although it might be better than if you have a gigantic document, like some of the Python official documentation pages that are just enormous. It might be better than trying to pass the whole thing into that. So yeah, that works pretty well. I'm not an expert on this, but I believe this is also used frequently in like a RAG system, which is retrieval augmented generation. I'm not an expert on this, but basically when users query a thing, it finds the closest section based on their query, and then you kind of prompt a chatbot based on the text from that section. Yeah, I'm not an expert on this. Other people have given talks on this, I know, at San Diego Python. But I believe that this could be used in that kind of a system in order to do that kind of a thing. Anyway, that's my brief introduction to pgvector. Are there any questions? Yeah.
The plugin is only for Postgres?
There are other plugins for other databases. pgvector is for Postgres. So I know there is a thing for SQLite. And if you define your model like this in SQLite, like this, it will generate, you can run your migration on SQLite, like in a test database or something like this, and that will all work fine. So it generates some sort of, I don't know, I didn't actually look, whether it's like a comma generated field or something, and you can save data into it, but you cannot run the cosine distance distance aggregation on it. So that will not work in test anyway. So if you're testing against SQLite, this can be tricky. Awesome.
Just a quick book plug. If you had read that book, you would know that you can do this locally on your machine a lot faster, a lot simpler, and a lot more accurately without having to pay anybody microcents for the privilege of sending out an API request over the internet and waiting for a reply.
Yeah, you're absolutely right. You do not have to use embeddings that are paid. There are a ton of local models like the sentence transformer package. You can use that combined with a bunch of different, you can download models that you can use inside of that, generate embeddings based on this. You do not have to use something like an API called OpenAI. However, I have found when you're generating millions of embeddings and you're doing this on like servers, this uses a lot of RAM relative to how much like web or Celery processes use. And I have found that API calls can be called more robustly than me running this model without spending a bunch more time on operations in order to make running local models more robust. So I'm sure I could do it on my own computer because my computer is like massively powerful compared to like a web server. But on a web server where you're running tons of processes and stuff like this, I found calling APIs to be easier to scale, I guess is what I will say.
I can show you some tricks that make it scale, more scalable.
I believe you. I do not doubt this.
It's free in RAM. You don't have to use RAM at all.
All right.
You can use the memory map.
Okay. Any other questions? I thought I saw one other one. Maybe it got covered. All right. That's it. That's pgvector. So, long story short, please sign up to give a talk next month. I am out of talks that I've all got prepared and lined up, so I would have to actually do one, which I'm going to try to avoid if I can. I do want to thank all of our speakers who did speak, which is also Trey. Thanks, Trey. You did great. I appreciate that. I also want to thank Qualcomm for having us and everything like that. And if your company would like to sponsor pizza at our meetup, let me know. But that's it, and that's San Diego Python. And if you want to chat more about pgvector, I like pgvector. I started using it like just a couple months ago, and it's been awesome. So, cool. That's it. Thanks for letting me use your computer, Trey.
Yeah.
So really, that's basically instead of using something like Mongo and use documents, you are basically applying that structure to your simple structure to be posted.
Yeah, it's just a column, like any other column. And the column just stores 1,000 integers. Or not integers, 1,000 books.
But for example, if you have already a structure in the database and you instruct the vector to say aggregate or correlate all this information or build new tables for building, semantic related data.
Let me just end the stream here and then. So
Libraries
you can
have more
generally